Good afternoon. Good afternoon. Welcome to this week's ITS seminar. I am very excited that we have Deborah Salon here. She is an assistant professor in the School of Geographical Sciences and Urban Planning at Arizona State University. But her real claim to fame is that her PhD is from UC Davis in Ag and Resource Economics, but she very much hung out over here at ITS. And in fact, when she finished her PhD, she was around for quite a few years as a researcher as a part of our program here. And I really miss having her around because she's the kind of person who is always coming up with interesting new ideas and interesting twists on the kinds of questions we've been asking. She's made really important contributions to the literature on the connection between land use and travel behavior, and is doing really great work on kind of the new stuff related to our Three Revolutions initiative here and other questions like that. So please join me in welcoming Deborah back to Davis. Oh, sorry. I got distracted. Okay, a little housekeeping business. You know, we're still kind of figuring out how our new system, for those of you who are involved in the seminar, is going to work. So things I want to point out is the sign-in sheet. Anne-Marie will be here till 1:45, and then she's gone. And so that's you have to sign the sign-in sheet by 1:45, or you won't get credit for being here. And then for the questions, we're going to give you till Sunday night to submit your questions. Most of you are doing it right away, but some of you seem to be forgetting. But you need to get that done. And then we'll debrief at the end of the quarter. If it's really not working, we can go back to the party system. But let's try to make that work. Any questions? Okay, and as long as I'm up here taking time away from Deborah, one more thing I want to remind you about is the mobility justice workshop / discussion group that's happening not every week, but periodically. Sequoia and Sarah are leading that effort. Next one is November 6th. And there's food, and yes, and I think I'm gonna let if you have to do a makeup seminar, you can do as a makeup attendance at one of these discussions. So let me know if you want to make that deal. Yes.
Can you save them up?
What?
Can you save them up?
Save them up? Oh, like go to this and then get credit for future. Yeah. You should just go and enjoy it. Really important material and in-depth discussions that we don't have time for in our space. Okay, anything else? All right, you're one of the families, so I don't feel too bad.
That's all right.
All right, please join me in welcoming Deborah Salon.
It's really fun to be back in Davis. So I see someone outside the room over there. Do you want to come in? Oh, no, I'm fine. Okay. There are seats over there.
Yes, seats there.
Anyway. So it's really great to be back in Davis. I lived here for a little bit off and on for about 15 years, so it feels very much like coming back home. It's awesome to see many familiar faces and a bunch of new faces here as well. So I'm really excited. So this research I'm going to be talking about today is work that I've been doing jointly with my PhD student, Matt Conway. And I've actually given this talk to a couple of other audiences, but I'm especially excited to give it here. And I guess because you guys are spending a lot of time thinking about emerging mobility services, so I'm a little nervous, but also curious what you all will have to say and what kind of questions you will ask me. So without further ado, start out. So I'm going to start out with a statement. The widespread use of cars in cities is unsustainable. I think that's pretty, yeah, I got it.
Do you have a microphone?
I don't, can you not hear me?
Okay, then fine.
Okay, I can try to speak a little more loudly.
Thank you.
So the widespread use of cars in cities is unsustainable. And this statement has really been the kind of driving idea behind all of the research I've ever done. I guess I'll say. And I really think that cars are extremely useful, but they cause a lot of problems. So I made a little word cloud, car-shaped word cloud of the various problems that cars cause. So you can see some of them on here. You can see I've got air pollution, traffic congestion, smog, property damage, death, ozone, et cetera, et cetera. So you can see there are a lot of issues. I'm sure you're familiar with most, if not all of them. So the types of sustainability problems that cars cause. And we all know too, right, that cars are expensive. They cost thousands of dollars to buy new, and plus you have to keep maintaining them and all this, and dangerous. Except when you compare those cars with other transportation options. So this is the main finding of this study. You can leave now, but I'm gonna elaborate a bit. But, so it's funny. I'm staying with an old friend and colleague here during my stay in Davis, Kurt Kornbluth, and he can't be here right now because he has another presentation he's giving. But I told him this morning at breakfast, or before breakfast really, I said, well, you kind of know, I'm going to talk about how cars are not as expensive as we think. He's like, oh yeah, that's why I have 6 of them. So, Kurt, just so people know, he doesn't, Kurt maintains, buys and sells cars, maintains them, he's a mechanic as well. That's why he has so many cars. But in any case, so there's this narrative that has been developing over the last number of years. Cars are unsustainable, cars are expensive, and so but there was always this narrative that people had about how but people need to own cars for some trips that they need to make, and so once they own their cars, then they end up driving them for a whole lot of other trips, and so that's kind of this structure of how we pay for cars was part of the reason that people kept using them a lot, even though maybe they were expensive. And so this new narrative that has come up is related to these emerging alternatives that provide convenient car access without ownership, and you're familiar with a whole lot of them. Some of them are in financial trouble at the moment. But I was just reading that in a news article this morning. But we're familiar with these car sharing and ride hailing kind of alternatives, ways that we can access cars. And there are these other emerging mobility options that are coming up, like accessing bikes on demand without having to own one, accessing these e-scooters. And so some have said over the last few years that car ownership may become a choice rather than a necessity for at least some US households, especially in more urban areas where these other alternatives are more prevalent and more easily accessible. And so what we did is, by ditching their cars, people could save money and the environment too, right? And start using these alternative modes and just access cars when they need them through these convenient alternatives like ride hailing and car sharing. And so just a couple examples. I mean, these are serious people, not only you guys. This was a quote from, actually the title of a February 2018 article in Automotive World: Could mobility services, new business models, and sharing economies spell the end of the private car? A little bit before this, I think when that was, yeah, I think in 2017, I was at a conference where I heard a very serious presentation by Deutsche Bank, by someone who worked pretty high up in Deutsche Bank, and he was an analyst of the automotive sector, and he had written a 75-page report on the extent to which these kind of mobility services and new business models in the sharing economy might mean that this whole sector of the economy was going to be more problematic for bank lending, such like this, like more risky. So these very serious people are taking this issue very seriously. So what we did, our research question, we've had two. So the first research question that we look at is how much are people in the US actually paying to own and operate their cars? And then as a follow-up to that, we compare that cost to some cost estimates for emerging mobility options. And we ask the question, will emerging mobility options soon actually make it economical for many Americans to shed their cars, reduce the number of vehicles that they own? And I have a comment at the bottom here, kind of a qualifier, where we say, you know, clearly money is not the only driver of behavior. I mean, I certainly know that. I've done a lot of studies on travel behavior where money is one of many, many variables that we include in the analysis. I think money is a very important variable. And I think that you know, people won't necessarily give up car ownership just because it saves them money. But I think if it doesn't save them money, if they're paying a lot more money to get around without a car, then they're not going to give up car ownership, because cars are pretty convenient, actually, ways to get around. So how do we do this? We used the 2017 National Household Travel Survey, which provided detailed information for more than 230,000 household vehicles that people own. And the information included in the NHTS was the make, model, and model year of the vehicle, various characteristics, demographic characteristics of the households, something about where they lived, and how far they drive their cars. So what we did is we put that information together with data from multiple other sources to try to estimate for each of these 230,000 vehicles how much we think that household paid to own and operate their car for the year annually in 2017, just for 2017. So what were the cost components that we included? We included depreciation for 2017, so annualized. So when I gave this talk last time, they said, well, one way you could explain that is, so I'll do it. I thought it was a good suggestion. So imagine that you bought your car used on January 1, or new, if it was a new car, but on January 1, 2017, and then you sold it on December 31, 2017. The difference in the price that you paid and the price you got is that depreciation. Yeah, so depreciation for 1 year. Insurance costs for that year, fuel cost, maintenance and repair costs, registration fees, and financing costs. And I'll talk a bit about how we estimated each of these. You'll see that some are much more precisely estimated than others based on data limitations. So how do we do this? So for depreciation, like I said, we're basically trying to get that. If you bought it new or bought it in the beginning of the year and you sold it at the end of the year, how much would that price difference be? So what we did is that we took, we matched each car in the travel survey, make, model, and model year to a very large sample. I think it was more than 1 million vehicles, 2017 used vehicle listings from a website called truecar.com. And so they were listings, not sale prices, which may be kind of an issue, but I think generally what people don't, yeah, if you're buying a car through a website like that, you probably pay something that's somewhat related to what the price was. And so we had the value, and then we estimated depreciation as a percentage of each car's value based on a regression model that we did. This was a piecewise linear, odd linear form regression model of car values and their ages. And there's some small print here about exactly how we did it that we could talk about if you like. But yeah, that's what we did. Basically, we matched to a huge database of car values and estimated the depreciation. For insurance, car insurance premiums depend on a wide variety of factors, as you probably know if you've ever shopped for car insurance yourself. So this may not be a complete list, but this was the list I came up with. So I think they vary, depend on characteristics of the car itself, in particular its value, something about the primary driver's individual safety record, demographic characteristics, and credit score, which of course we have no idea about that. The address where the car is insured. We did not get the addresses from the NHTS, but we do know what state people are in, and we do use that information. How far the car is driven, more or less, each year. Lower mileage drivers pay less in insurance than higher mileage drivers. Whether there are multiple cars in the household, insurance companies, it turns out, give multiple car discounts. So if you're insuring one car, the price will be one amount for that car. If you're insuring two cars, you generally get a 20 to 25% discount on your insurance price for each of those vehicles if you go through the same insurance company. If you're not getting that, you should argue for it with your insurance company. And then, very importantly, there are different. You have a choice when you buy insurance. How much insurance are you going to buy? Right? So some people will buy very high liability limits. Some people will buy the full comprehensive collision kind of insurance. It turns out that depending on what choices you make, you pay a very different price for insurance. So we had to make some assumptions about that based on household characteristics. So this is the information we actually had. We knew the characteristics of the car. We knew something about the demographics of the primary driver. We knew how far the car is driven, and we knew whether there are multiple cars in the household. We had the state, although I didn't highlight it, we knew the state where the car was insured, although it does vary within states. At least we had that. And we made some guesses about this last bit. But we know nothing about safety record or credit score. So what we actually did do, what we used for our data is we used average insurance costs by driver age, state of residence, and our guesses at the amount of insurance purchased from this website, carinsurance.com, publishes that information. And the small print on this is the assumptions we made about how much insurance people bought. We assumed that cars with values above $10,000 required comprehensive and collision insurance because they were worth it, essentially. And that higher income households selected more liability coverage because they have more to lose. So these were our somewhat imperfect guesses, but that was kind of the best we could do. If anyone has any suggestions on improvement, I'd be happy to take up that. But that's what we did. And then we gave them multiple vehicle discount, 25% for households with more than one vehicle. So for fuel costs, this is a lot easier. We did know how much fuel each vehicle consumed. We had a pretty good estimate of it because we knew the exact make, model, and model year of the vehicle. We matched that with EPA fuel economy database. So we actually know the fuel economy. We also know how far, hi Alan. We actually know how far each car was driven. There's an estimate of that in the data set. And so we did some multiplication. Oh, and we also know something about the price of gasoline in the region where that car lives or where the household lives. So the fuel cost is a function of that. So fuel cost, our estimated fuel cost is price of gasoline times how far they drove divided by the fuel cost. Pretty straightforward. For maintenance and repair costs, we used the 2016 Consumer Expenditure Survey data on car maintenance and repair. By age, and by vehicle age, and we divided vehicles into what we call luxury and non-luxury makes. So it turns out it costs more to maintain and repair a luxury vehicle than a non-luxury vehicle by a significant amount. And we ended up with making an estimate of the per mile maintenance and repair costs, and then multiplied that by how far people drove their car. So the more you drive, the more you got to pay to maintain and repair your vehicle, and if you have a luxury or non-luxury make, that will matter, and also the age of the vehicle. Newer cars need less maintenance and repair than older vehicles. So we use this data set to run a regression to estimate this stuff, and this is what that estimate, the regression looked like. So you can see we divided vehicles into these year, age bins. This is the luxury vehicles. Over here we have what we call proletarian vehicles. I have to give Matt credit for that. He came up with that word. But anyway, this was the regression we used to estimate how much vehicles cost to maintain and repair. And then, second to last, for registration fees, each state, sometimes even more local than state, but we didn't have that data. Each state has very different formulas for how they charge vehicle owners to register their vehicles. Very fortunately for us, there is a group, the National Conference of State Legislatures, published a complete guide to vehicle registration fees and other annual vehicle taxes by state. And so we used that to estimate fees for each car in our database. It was a little complicated because we didn't always have quite all the information we needed. Some states charge fees based on weight, others charge based on age, some charge by vehicle type, etc. But we did our best to estimate those fees. It turns out those aren't a large fraction for most vehicles of the total cost, so it's not really that big a deal to get them a little bit wrong. And last but not least, we made a pretty straightforward assumption about financing, which was just, we took a conservative approach and assumed that all cars were financed if they were less than 16 years old. We used a flat, essentially, interest rate and amortization schedule and the value of the vehicle, and we just added that to the amount that they paid. And you'll see why this is important. I mean, you might think, well, if we just add an inflation factor to everybody, why does that matter? Well, it matters because we're going to be comparing these costs to the costs of other alternatives, emerging mobility alternatives, and other alternative modes. So actually, the real number matters, not just the relative. So one thing that is clear is that parking costs are not included in our national estimate. I will show you scenarios where we do make some parking cost assumptions for denser and medium density urban areas and how that changes the results. The reason we don't include parking costs is, in case you're probably already aware of this, but essentially that most Americans do not pay to park their cars most of the time. In fact, they've stopped asking about, on most travel surveys, including the 2017 NHTS, they don't even ask about whether how much people pay to park their cars, because so few people ever answered that question when I asked it before that I think they decided it wasn't worth asking. The couple surveys I looked at historically that did ask that question, 99% of trip ends had 0 parking costs at them. Yeah. So that's why we don't include parking costs, but we do a scenario that does. So what do we find? So this is what the distribution looks like per car ownership costs. Car ownership costs are quite highly variable. You see that, some people are out here paying $10,000 annually per year to own the car, and some people are down here paying, less than $1,000 to own their cars. But most people are kind of in this range, but that's still a pretty wide range, $2,500 to $5,500-ish dollars per car per year. When you then narrow that, and part of that is due to how much they use their cars, part of it is due to how new the vehicles are. You narrow it down and start looking at the cost of ownership per mile. Well, I don't even know if this is actually that much narrower. Maybe it's just narrower because the scale is kind of wider. But the median cost per mile for owned cars, based on our calculations, is 39 cents. And you might think, wait a minute, if I used my own car or my private car and I get reimbursed at the federal reimbursement rate, isn't that higher? It is. It's much higher, right? And it's funny, my colleague said, yeah, it is. And that's what they do to calculate that much higher rate is they use the American Automobile Association's calculations of how much it costs to own a car. And those calculations are made for only vehicles purchased new for the first 5 years of ownership. So they have huge costs for depreciation in them. And I said, well, why does the AAA want to make it seem like it's super expensive to own cars? And my friend said, because all their members want to get that high reimbursement rate when they drive them. I don't know if he's right, but yeah.
But so I appreciate the perspective, and of course AAA is going to do that. But there is, so if you look at the actual out-of-pocket costs for somebody who buys a car new with a 5-year loan, that's actually more representative, right? So I understand what you're doing is taking the depreciation. So like after a 5-year loan, you own an asset, and so it's valuable. But in terms of what you're actually physically paying over the 5 years of that loan, you're going to pay a lot more than what you're calculating.
I'm not saying the AAA is wrong. The AAA's numbers are great. 4 cars purchased new for the first 5 years of ownership. But if you want to talk about how much Americans, the distribution of what Americans are paying for car ownership, I think this is more real.
Well, so what I'm saying is, so for the case of a car purchased new within the first 5 years, your auto payment is going to be higher than the financing cost plus your depreciation estimate, because you're also paying off the principal of that vehicle. So my understanding is you're about 2 capital costs in here, right? The financing costs, which I think I understand, and the depreciation cost. But you're amortizing the depreciation of the whole life of the vehicle. Whereas if you take most common loan is a 5-year loan.
No, but you're thinking about then at the end of that, at the end of those 5 years, your vehicle isn't worth anything,
Right.
which isn't true. Because it is. If you then sell the car, you get the money back.
Right, but I'm just talking about out-of-pocket costs. Like, what are you actually spending out of your checking account is going to be more like the AAA number. What your net change in your sort of whole account value would be more like what you're doing here. So it's just a question, I think, of what it's being used for, right? But for out-of-pocket costs, like, I've got a loan for my car, so I write my credit union a check every month that's higher than the depreciation value and the financing together.
Yeah, I
So
mean, I guess it's the same as you could argue about for like, home ownership and all. Anytime you have a depreciable asset, right, that you're, yeah, for sure. Anyway. So then we divided this up into the fixed and variable costs. So this is the distribution of only the variable costs. What by that I mean fuel and maintenance and repair. So the costs that vary with how far you drive the vehicle. And this is the total amount. Overall, a little bit more than half for Americans of per mile cost of fixed paid, regardless of how much the car is actually driven. It's actually much higher than that for newer vehicles and can be lower than that for older vehicles. This is perhaps a more interesting number, at least for our purposes today. The distribution of average variable car cost per mile is reasonably narrow, right? So just fuel and maintenance costs don't vary a whole lot per mile. And that this number, the median number, is only 17 cents. So we took those distributions and to get an idea of who might be able to save money by ditching their cars, we created, it's not a real demand curve, I put it in quotes, a demand curve for vehicle shedding. So it's not really a demand curve because it's only about relative money prices, not based on preferences or anything else that people might like about cars, but versus other alternatives. But it gives you some, it's interesting, you'll see. So what we did is for every average price point for alternative modes, we illustrate the fraction of households that could save money by shedding at least one vehicle, the fraction of vehicles that could be economically shed, and the fraction of VMT that these vehicles represent, current VMT. So this is what it looks like. So to give you, you see the red line is households that could economically shed a vehicle. The yellow line is owned cars that could be economically shed, and the green line is what fraction of the current VMT those represent. How to read that? So if the average, so imagine that your average cost per mile for alternatives, like if you shed your car and you needed to do those that transportation service using alternative modes, whatever you had been doing with that car before, you figured that it would cost you $1 per mile between car shedding and or between car sharing and ride hailing and biking and transit and whatever else you're going to do to get those trips done, maybe, and using your other owned car if you have multiple cars in your household. Imagine that cost you $1 per mile. Then our results indicate or estimate that that would be 10% of owned cars in the US that could be cost effectively shed, but only 2.4% of the current VMT.
And you're assuming that it's this exact same travel pattern, so people don't modify their trip behavior at all when they don't own a car?
So we're not necessarily assuming that, because we actually, so one of I think this analysis, as you'll see, is sort of illustrative of I think how inexpensive cars are. And each person is going to have a different answer to how they would do that travel, right? So some trips would be not taken anymore at all. So, or some trips might be shortened, or they'd have different destinations, or, you know, so people could definitely alter their travel, but in order to sort of meet whatever, you know, the transportation service demand that vehicle had previously met, take that vehicle away, okay, now what are you doing? That's what it is. So for each person, it's going to be, and each household is going to be different.
So it's $1 per car replaced mile, not per mile that you do with the replacement stuff.
$1 per, yes, I guess so, yeah.
And the VMT reduction is only for the owned vehicles, right? So there's still probably half of that is now VMT and other
vehicles.
ride shared or car
Yes.
shared.
Yes. Yeah, so this kind of maybe clarified. So the average price per mile for own car alternatives, the average price for the bundle of alternatives that a household would use if they shed a car, to be a different mix of alternatives for each household, depending on what's available, what their needs were. And you know, at this point, as cars are shed, some trips currently taken in owned cars would be shortened or not taken. So we're not assuming necessarily that there would be no travel behavior change. So for any of these miles, the cost of the alternative would just be zero. So you could average some zeros in if you really think you could, if you didn't have a car, a particular car, you could meet some of that transportation need by just, I don't know, e-shopping, for instance. Then you'd have zero cost or the cost of delivery or whatever it is, right? So, yeah. So getting to our second research question, will emerging mobility options soon make it economical for Americans to give up car ownership? So for this, we have to take our curve and figure out, well, how much are these other things costing? And so I'll show you. So the first thing we did was we looked at traditional, what I'm calling traditional alternative, not necessarily sustainable, but alternative mobility options. And these sustainable ones mostly cost less than owned cars on a per mile basis. Not for every person, but mostly. So walking is quite cheap, biking is quite cheap, transit is quite cheap. I'm sure you have questions. How did I come up with these numbers? I will tell you. So transit, this is actually available from the National Transit Database. And this is just the average cost per mile national of public transit service provided. And I think, you know, you could certainly think about modifying that number and making it different for different metro areas, different transit systems. It's going to be different in different places. But when we started thinking about doing that, we realized how complicated it is because a lot of places have, you know, passes. So people buy a monthly pass, and then how many miles are they traveling? And, you know, or a weekly pass, or, you know, and have different modes that have different pass systems in the same metro area. Anyway, we gave up and decided, at least for now, we would leave for future research, doing a better job of figuring out the per mile cost of transit, and we leave it at the national number. Biking and walking, so we came up with these numbers ourselves. The way we did is for biking, we're both bike commuters, and we thought about adding up, well, how much do we spend if you're biking for transportation? How many miles are we biking per year? How much do we spend on our bikes? And came up with this number for, you know, some amount of bike purchase cost and maintenance, essentially. And for
food in there.
we didn't put food in there. No calories. We're figuring exercise is a bonus, right? So
What about value of time?
we don't have value time. This is all just money. Yeah. And then for walking, now this might be I don't know if it's an overestimate or not, but the way I thought about that was, if you're really, imagine you're walking for transportation. you gotta replace your shoes. And we figured a pair of walking shoes, like maybe $50, maybe more, maybe less. And you get like 500 miles out of it, and then you get 10 cents. So, rough numbers, but I don't think they're totally wrong. And car rental is actually relatively inexpensive because most people,
Cars
when,
are inexpensive.
what?
Because cars are inexpensive.
Well, and also because when you rent a car versus you'll see car sharing a lot more expensive. Car sharing and ride hailing is much more expensive than this. The reason that car rental comes out relatively inexpensive is that when people rent cars, they tend to drive them a lot of miles.
Yeah.
Yeah. So it's a little bit of a purpose, the particular purpose for which people rent cars.
Do you factor in insurance in the car rental? Like the
To be factored, I have to say I'm not sure. The way we did this is we used numbers from the Hertz company, from their financial statements. And so if I recall correctly, this 75 cents was what we think, there were numbers about how many cars they had and what their revenues were, I think, from car rental business. And we divided those, and then we divided by a very, very, very rough estimate of how much car rental cars are driven per year, which is about 20,000 miles. And that's how we got that number.
But the case is that car rental punish the households that have no cars, because then you have to take an insurance that double the cost per mile.
Yeah.
And so if you already have a car, your cost per mile will be much lower than if you don't have a car.
Yeah, so this may or may not, I would have to look and see if those revenues included the insurance or not, and I'm not positive. I'd have to go back and look. It's a good question. I'm not sure.
because it includes it, it's already weighted in number of customers that get insurance. But if it does not, as Gil says, it could go much higher than that.
Yeah, for sure. And so here's where we add in these emerging mobility options, and you see that as they come in, they're all higher in cost. So how we got these numbers? So for shared bicycles, this is numbers from the City Bike program in New York City, which is probably cheaper than a lot, per mile. Shared e-scooter, that's just taking the Lime and Bird kind of pricing model and imagining. I actually don't remember the specific numbers. I think I said, let's take a 2-mile trip. What would that be, and how long would it take? You come up with something like this. And there are a lot of estimates in the literature for how much ride hailing might cost per mile. There are very few for car sharing, but all of them are kind of in this range. At least 150 is certainly the lower bound of the price of ride hailing, and they go up to $3. I've seen $3 per mile. So I guess when you look at this, you think, well, wow, these emerging mobility options that we're also excited about are just much more expensive than owned cars, and also much more expensive than our more, old school traditional alternatives to owned cars. So this is the main finding of our study. And not for everyone, right? I mean, there are people out here that pay a lot for their own cars, and they could do well. They could do well to shed their cars and use these alternatives. It's not a whole lot of people, at least nationally.
And those would be the expensive luxury cars too.
And a lot of them
So
are the
they're not
expensive luxury cars, low
trading that in for
mileage.
Uber X.
Yeah,
So
they
they're
probably
low
don't want to
mileage
give it up.
And it's worse, so many of these are subsidized either by venture capital or public subsidies. So,
Yes.
so
So the real cost of this stuff is probably even
Higher.
higher than
Yeah.
consumers are seeing. Yeah. And here, in
You
this,
should add traditional taxis in there. I think that would be
of reference.
for some of that, yeah.
I think traditional taxis are up here too. Yeah. I think they're really expensive. But remember the owned car that you have already, that you're only talking, this is the variable cost of owning, the median variable cost of owning a car. Remember that was like between 15 and 19 cents per mile. So this is if you have another owned car, that's like one of your best options for getting around. So, like I said, sort of the main finding is that emerging mobility services, with this, if we're right about the prices of all these things, we think that emerging mobility services are unlikely to induce widespread shedding of owned cars. Actually, I just this morning read an article on Wired that came up with the same conclusion. But without doing this analysis. But there's some, but what about subgroups? And, you know, are there some groups for whom this isn't, our main finding are not true? That was a national finding. So we did some sensitivity analyses. So we looked at how these findings change. We look at different types of cars, households, cities. The answer is basically not much. I'll show you. By vehicle type, we see that, you know, SUVs, pickups, cars, and these are kind of mostly unique, you know, household vans, minivans, not big vans. Kind of as you'd expect that cars and vans are less expensive than pickups and SUVs. But the main findings are not going to change. Luxury cars are more expensive than non-luxury cars. By about the same difference as you see between the most and least economical car type, between cars and I think it was SUVs. What was it? Pickups, actually. Least economical. At car age, it does matter. You know, cars that are relatively new, between 0 and 5 years, are much more expensive than anything older than that because of the depreciation. You know, most of the depreciation does happen in the first 5 years. You do get that outcome. We looked at also the driver to car ratio. So the red line is households that have more drivers than cars. The yellow line is households that have drivers equal to the number of cars, and then the green line is the households that have more cars than drivers. 23% of households, according to NHS, have more cars than drivers, which we found astounding. But in any case, those predictably are the households that could most economically get rid of one of those cars, because presumably they're not driving them as much. Right? They don't have enough drivers to drive their cars along. So we did a little regression. R-squared is extremely low, just 0.07. But looking at, you know, how do these different factors maybe come together to predict the household average cost per mile. And you do see, we added in some density stuff. You do see that density does start to matter. If you're in high density in New York City, your cost per mile is 6 cents per mile higher than otherwise, which is significant, right? And there's some other things that are significant. Oh, I didn't show you the graph, but being retired has a big effect. That's because retired people don't drive as many miles, and they're more likely to have extra cars. So, yeah.
And the New York numbers, that doesn't include parking still.
Correct. Does not yet include parking. We'll get to parking. Now. So how do these findings change when we add parking costs in what I'm calling medium and high density neighborhoods? So, and the answer is quite a lot. So in the NHTS, we don't actually know, we don't have the geocoded version of the survey, so we don't actually know precisely where people are living. But they do include some census characteristics of the precise area where people are living, including the density of the block group where the household lives. So we use that. And we just did a scenario where we made some, I think, mostly kind of extreme parking cost assumptions, but just to see, you know, how much these move the needle. They move quite a bit. So the scenario that we did is we imagine that in sort of what I call medium density, this is like Davis density-ish, I think, 7,000 to about 17,000 people per square mile. We add $100 a month per car. So imagine, you know, maybe if you park at UC Davis, it's only $50 per mile, per month. Oh, okay, so yeah, for instance. So this is an overestimate, even for here, where you guys pay quite a bit.
Well, what about, how many of you pay extra for a parking space at your apartments?
Yeah, exactly.
Or if you wanted a parking space at your apartment, would you have to pay for that?
Not much.
Nobody?
Davis.
Not Davis.
I thought
I
they were
don't
doing
have a
that
car, but they
already.
pay in my place.
Yeah.
That people pay more.
Yeah,
I don't know how much it
complex.
is.
Yeah.
It's very complex. You need to pay for a parking space.
Yeah.
To me, it's an underestimation of the real cost.
Yeah.
In medium density, like, you know, you probably pay easily 100 per month for the car in, like, you know, I know many places in the Bay Area, they pay 100 plus just for the place where they live. But
Yeah.
then you need, every time you park somewhere else, you need to pay more. So like, you know, it sums up in a month probably much more than that.
Some,
How's the
but I think
high
not many
density
people.
different?
Yeah, so in the higher density where we
Probably
have
that's-
quite a lot of people, 17,000 or more.
I can tell you that parking spaces in Walnut Creek are in the order of 100 per month. And we're talking Walnut Creek probably is below 7,000 per square mile.
I don't think it
Bay
is.
Area.
I don't think it is. So I've seen, again, this is the part that I kind of wish I'd done before I got here, but look at, you know, create a map of actually where this is. But just from, my colleague was doing some stuff like this and showed pictures of like a 12,000 person per square mile density, and it looked a lot like Davis. That kind of Davis, single family residential, but relatively
Davis
dense.
is pretty dense.
Yeah, it's relatively dense, single family residential is sort of in the 10,000.
So I wanted to say, like, you know, the 100 miles, probably many places that are medium density, that is the price per your residence. But then every time you park, you need to sum up more.
Maybe, but most people, like in this room, not a single person raised their hand and said they had to pay at home.
I think the Bay Area is the outlier here.
Yeah, and
Most
I-
other places in the US, even at
Yeah.
medium and high density, they'll pay for
Yeah.
And also the Bay Area, your employer gives you free parking. And no one pay for parking at Google or Apple or any of these places, so, yeah.
Yeah, even I know there are people in our field that have done work on some really great work on parking costs in New York City. And even they find that a whole lot of people who own cars in New York organize their lives so they don't have to pay for parking. And you think like that's gotta be a place where people pay for parking. They don't necessarily, not all of them, some of them do, a lot of them don't. Anyway, so, but we came up with this scenario with these, just these numbers that we threw out there as we thought, I think as an average, they're pretty high. Let's see. So here, so what is it, what does it look like? So this one is, what does it do to the national curve? It moves it a bit. And I think we need to go back here. Well, we have to go back pretty far. Anyway, I'll say it moves it a bit, but it's not a huge movement. I mean, this used to kind of, you know, come down more like that. We moved it over some, but not a whole lot. You still see that for most people, all of these kind of emerging mobility options are not gonna get a whole lot of car shedding or VMT shedding. Right? It used to be that $1 was the 10% mark, and now it's like 15%. If we you know, just graph the people who actually live in these medium and high density block groups, it moves it quite a bit more, right? So for the $1 mark now, it's up to nearly 25% of vehicles that can be economically shed at $1 for alternatives. And if we just graph the high density block groups, then it gets up there near 40% could be economically shed. So it moves it quite a bit.
Yeah. The car rental thing is interesting. Yeah, because that could be bigger. So if you're in a place where you can get around by transit, walk bike most of the time, and occasionally need a car, then having an easy car rental option makes it possible to not own a car.
Right.
Much more so than these new services.
Right.
Yeah.
Yeah, I think so.
Yeah, it's surprising that car
Yeah.
sharing is so different from car.
It is,
It's
you know,
expensive.
it is expensive.
I've never.
Yeah. It is expensive, and this is based on one study. We only found one study that estimated the per mile, had anything related to the per mile cost of car sharing.
Yeah, well, the
Yeah.
per hour is so much more than.
The
Right, that's
issue,
true, right.
the issue is
Offers
for car
more
sharing, you
different
pay,
way,
it often you're paying to drive to your destination and then have your car sit there while you do whatever you're doing. The per hour rate is quite high, and then you're driving back.
I suspect that
Right.
those numbers change a lot if you look at like the point A to A car sharing where you need to return the car in the same place where you picked it
Yeah.
versus car
You would-
to go type of
Yeah,
service
you
where you
would
can
think-
leave it in the
I think
destination.
that, I'd have to look back, but I'm pretty sure the study looked at those two types.
And I mean, so like I rent my car on Turo for $63 a day.
Oh, you do? Ooh.
Well, because I want other people to get to drive electric vehicles. That's the way I do that. And that's includes 200 miles. So it would be, if I quite a bit cheaper, but it probably varies a lot depending how far you drive it, right? You get it, like a lot of people get Zipcar to go to IKEA. So then that's like 2 miles or something each way.
But so that's a per day, right?
$62 a day, yeah.
Yeah, so per day, that's more like the car rental.
Right, yeah. Okay,
Yeah.
Now we have gig card.
Yeah,
Oh, yeah.
well, so that's where you get this whole range, right?
So nothing.
Including, yeah. And some people have come up with, well, you know, in the future, when we have, I don't know, when we have AV shared ride hailing, then they've estimated that these prices will come way down here, but I just don't know that I believe that. I think, I don't believe it at the moment. Maybe I'll be proven wrong, but these are the data that we have. Yeah, so this is my last substantive slide. And so what I think we conclude is that even in this world of technologically enhanced and really exciting mobility options, traditional solutions for sustainable urban transport are really important to remember. And the big one is we need to make cars relatively more expensive if we want people to stop using owned cars for almost everything. Local governments have a lot of control over parking, both prices and supply. And Gil, do you want to tell your anecdote you told me this morning?
Oh yeah, so I was in Copenhagen last week, and we had a day tour with the technical mayor, which is the city manager in the US. And they're doing a lot of bike lanes and all of that, but the secret sauce that is not on their brochure is that every year they take off 2% of the parking spots and change them into something else. It's bike lanes, it's bike parking, it's transit stations, but actually in the last more than 25 years, they take 2% of the parking spot every year, per year. And that's probably the big push.
Try and do that, even in Davis.
Well, slowly, 2%.
They never put a
slowly.
ban, they never say.
Yeah,
Very
yeah.
slow.
It's like in Tokyo, if you wanted to buy in order to be allowed to buy a car, you had to demonstrate that you had off-street parking. And the moment you've incorporated that cost in there, then your curves will shift significantly.
Oh yeah, yeah. If you include that cost of the garage, it's huge.
Yeah.
Yeah.
It's actually a question for Gil. When did it start to do the increasing of the 2% of parking? She said 25 years, right?
I heard 20 or 30.
Oh, when did they start?
When
Between
did
one-
it
start?
So he was not, he said between 25 and 30 years ago, and he said that this 2% is actually getting smaller every year. Back then, they kind of took off a lot of parking, and now it's few every year because it's like less.
Like,
than
right.
The base is getting
The base is
smaller.
getting smaller, yeah.
The more you take out.
Yeah.
Well, a lot of cities here in the US are removing the minimum parking requirements.
They are.
Yeah.
They are. We'll see what happens. They are.
That's like slowing down the accelerator though, not hitting the brakes. Right?
Yeah, and then invest in sustainable alternatives. They're already cheap. If we make them safe and convenient, then they could compete better with cars. These are not new solutions, obviously, but I think that in a lot of the discussion and hype around all these new, exciting alternatives, we forget about how cheap cars are. I mean, we never knew really how cheap cars are. And I would love to see, the reason I was really excited about coming here and giving this talk is that you guys have much better access to people who are actually making policy than, say, I do. So I think it would be really, really awesome, and I'd love to help, try to re-communicate this message of pricing matters a lot, and we can't just hope that creating new options without changing the price of driving is going to do much. So there's some other things we want to do with this. We'd like to think about the external costs of car use. Look, like I said before, more carefully at variation across cities. Maybe look at some of the value of time stuff. But I think that this analysis is I think it makes a big point. And then I want to say thanks for your attention. And Giovanni.
So this is very fascinating, and it also confirms insights that I think many of us have been looking at, that the potential for replacement of cars with new mobility options is not that big, and it's mainly focused in New York, Chicago, Boston, San Francisco, big cities. I was wondering, in your geographic component of the analysis, if you've been looking at the distribution of various cities, in particular because, like, in the urban areas, not only you have the higher parking costs, but you have also people that drive less on average, fewer miles.
Mm-hmm.
Do you tend to have people that have a higher income? They often have more expensive cars. So you have some, like, and so how that proportion of people that could be better off with having other alternatives increases, like, the more you move into like a downtown area, in the central core and so on. And also it's the places where it's more rich in terms of alternatives. Because,
Yeah.
Transit is a potential alternative, but most people in the US, they don't have places to go with transit.
Yeah, so you hit on a whole lot of things that are true. There are a lot of different trade-offs between people who live, and different things about this. The car cost analysis happen for people who live in downtown versus people who live in suburban or rural areas. It turns out, so we made in our sensitivity analyses where we looked at different segments of the market. I didn't show it, but we have one for different densities. But it turns out density doesn't really matter at all. They're all right on top of each other. But I think the reason is what you just said, that people who live downtown drive fewer miles, so per mile it's more expensive. And the people who live downtown, they own fewer cars. They drive those cars maybe fewer miles. They might have more expensive cars. You don't end up with really I'm not coming up with a very clear discussion of this, but I remember looking at it and thinking, well, at least on a per car basis, density doesn't matter. People who live downtown own a lot fewer cars, but per car, their cost per mile is not too different from every place else.
Because I think that, the question really related to your research that is very, very much of interest for many of us here is really how many of the people that could afford to own a car decide not to own a car. And I think, like, if you look at the data from ACS or, like, in the US, it's about 10% of households in the US, they don't own a car. Most of them is because they cannot afford it. But the niche of the people that could afford it, that decide not to have it, is very, very tiny.
And they're all in downtown areas.
In San Francisco, New York, and Boston, and so on. And so the question is, how big is that pie at today's very tiny slice? How much it could grow?
How much should it grow? Yeah.
But it's fascinating. Yeah.
Thanks for your presentation. I've been thinking a lot about how this might look with the equity perspective and framework kind of integrated into it. And I've been thinking a lot about the trends here, like especially in California with, or any kind of or urban zones, with the haves coming back into cities and pushing out the have-nots further and further and being forced to drive farther and farther distances to access jobs. And so I just think it's really interesting to have this information, but I think like that next level that I want to see is how the impact of these prices based on how much money that you actually earn, and like that would be so interesting for me to utilize and see and to support, spending it on your recommendations in areas that have been classified as like higher need instead of just like a blanket solution of, invest in infrastructure, but if there's already infrastructure or people already have a lot of options because they have a smartphone, what about the people that can't access that, or that don't have a driver's license, or that don't have a house?
Right.
So that's like that next level that I would really love to see.
It would be, I mean, I actually don't remember if I did this, but an obvious thing to do with this is to look at how this varied by income level. I mean, for sure, lower income people have cheaper cars. So,
but they're driving such long distances, and the proportion of their income is going towards travel.
The proportion of their income, I don't know that they're driving necessarily more.
for example, in the Bay Area, which is where I'm from, like people being pushed further and further into the suburbs, still needing to come back.
I totally get it,
Yeah.
yeah, but if you look at the overall averages, I'm not sure they're driving more than people with more money. Maybe they're certainly driving more than they used to, right, when they were living.
They may not be driving to Tahoe every weekend.
Or like
Yeah.
rural people not being able to access stores or being like in, you know, it takes 3 hours to get to doctors, but like that.
Yeah.
Yeah.
We don't know how much driving is by choice versus necessity.
Right, yeah, we don't.
There are services, bus services that are private, but semi-subsidized by federal funding, such as we have in Sacramento, in West Sacramento, VIA, it's called VIA. So we're wondering if you guys included that in your analysis or thinking of the analysis and see what's the effect.
Yeah, what is it? Yeah, I mean, so I haven't seen any estimates of like the price per mile for VIA.
But the
Yeah. Yeah.
subsidized ones, in cases like that where they're subsidized through the transit agency, are probably included somewhere in the transit data. Even though they're still,
Yeah.
but I mean, it would be nice to see it separate, but
Yeah.
it's still a small percentage of what.
So it seems like one of the secrets here is figuring out what the value people place on their time, and that's affecting their decisions to choose transportation. So we really need to better understand the value of time and either figure out ways of changing those values or improving the or reducing the times, I guess, or something. I'm not sure, but I feel like that's what's missing in your analysis. And then partly I connected to this is these are sort of averages, and there may be these niches that are very important.
Right.
That once you begin to examine those niches, you'll find, oh, this group has the right combination of attributes that suddenly they have a very high utilization of these features.
Mhm.
And so how do you find those attributes and put them together and first identify them, and then how do you eventually supply them? Supply them as a policy.
Yeah. So I mean, so to answer your value of time thing, I mean, value of time is important, but I actually think it would make these results more extreme, right? Because
Worse,
yeah,
Fastest is always going to be driving your own car.
yeah, driving your own car is always going to be the least time. So it makes the story even worse. Right?
I know, and that's what it almost makes me wonder. Why are those people even walking and riding bicycles?
Anyone, right?
Yeah, it just doesn't. It's not rational.
No.
So sorry, Susan. And so why? So we better understand those people and what combination of attributes of those.
I just submitted a paper about what people like about biking, the positive utility they get from biking.
Yeah,
There were a couple back here.
yeah. But I guess, well, actually, I think you had your hand up first.
And thanks for your sharing. And I was wondering, what's the contribution of each type of cost to the total cost?
Oh yeah, I actually don't have those slides here, but what it looks like is essentially for new cars, it's a lot of depreciation. I was like 60-70% depreciation for new vehicles, and then the depreciation part of the cost, fraction of the cost goes down as the vehicles get older, and the total cost goes down more or less as the depreciation goes down. Maintenance goes up a little bit, so that's kind of what it looks like. Insurance is substantial.
How about the fuel cost?
Yeah, fuel cost is substantial, but not that big because fuel's not that expensive. Yeah.
So, I was wondering, is there a significant difference between the electric vehicle cost and the gasoline?
Okay. So Bill could probably answer this almost better than I could. I mean, I've done a little bit of looking at this in a different piece of work.
You have a TCO on EVs.
What?
You have a paper on TCO.
I know, I do, yeah, I do. I have another paper on cost of ownership for EVs and comparing. I mean, we just picked out a very specific, like one type, one model of EV, one model of hybrid, and one model of conventional vehicle. We did a 5 and then a 10-year cost of ownership model for each of those. And at least for the particular vehicles we looked at, we found that EVs were more expensive. The question we were asking there was, do EVs still need a subsidy? And our answer was yes, because they're still more expensive. But yeah, so I think the cost numbers don't look better for EVs is my guess. I think that that other work that we did has changed probably since with newer models of EVs, but still I think you're not going to get a happier answer with EVs. Yeah.
Thanks for the presentation. Thanks also for advocating public transport. Most of my research, so I'm kind of not sure if that's just a question. Do you have related to this? Because of course this is very interesting, but the problem is, okay, can you really use public transport instead of cars? And that depends on of course, on the quality of the supply that you have. So you have any idea of how this could be included in your research to see how much of this potential could be actually exploited?
Good question. I'm not sure. So I'll tell you, this whole project kind of started a couple of years ago when I was talking to Matt, my PhD student, and I was like, well, he was in the process of writing a proposal. I forget even for what. And I was like, I know. Oh, I think it was an NSF grad fellowship, which he didn't get. But he also didn't take my advice on what to write his proposal on. Anyway, that's really awesome. But anyhow, so this was what I thought would be neat, and he didn't take my advice because he thought it was going to be too hard, and I agree. I thought, I wanted to explore the idea of the marginal car. Like, who has these cars that they could give up in favor of alternatives? And then for that, you need to come up with, what do those alternatives really look like? You're saying, like you're asking, how do we figure out who has the capability, given whatever public transportation and land use scenario you stick them in, who really has the capability of giving up a car and reasonably replacing it with these alternative modes? And it's just a really hard problem. It's a really, really hard problem to simulate a whole world. And it's a hard problem that I'm just not sure, even if you did that full simulation, that the answer would be believable. I'd love to brainstorm though about how you might actually do it, because I think it would be a valuable exercise to think about trying. Anyway, I see this as kind of one of the first steps in that process, but I think that's a really important question. It's related to what Alan was saying. You're trying to figure out, like, well, who could be the niche markets that could do this if we just supplied them with, more convenient transit, or, better, accessibility around their homes, or something like that. But it's a really complicated, hard question. Yeah, back.
Are you including the cost of vehicles in places where there's no alternative? So there's no like public transit in rural areas, like vehicles are cheaper. So it kind of skews the comparison.
What?
Like a vehicle might be more expensive in San Francisco, but it's more pertinent to like compare it to public transit there. But if you're comparing like a rural area where there's no alternative, like a car is like $2,000, like that changes your comparison.
Oh, the market differences.
Yeah, I mean, I think, well, like I said, what we found was when we looked at the differences between home densities, as for the per mile cost of car ownership, it wasn't that different. So it's actually not that different, I guess, at least on average. That's what we found. Yeah.
Sorry, not to go back to the time value thing, because everyone's already said it, but I was just thinking, so like time value changes throughout the time of day that you're traveling. And oh my gosh, I just forgot what I was going to say. Oh my god, everyone's looking at me. Look away, it'll come back. Oh, gosh, yeah. Sorry, I thought everyone wanted to be.
Send it online.
I can't. Alan has another
One question. Did you include tolls?
No.
Because in some groups, some situations, tolls are a significant.
Tolls can be
factor.
important, yeah.
And also that maybe a driver indicator where people switch to public transportation or something.
Yeah, I mean, I think that, I think the tolls and parking and, you know, carbon taxes or gas taxes or something, that's all part of this.
I agree.
All right, any students?
Oh, for students.
Yeah.
So the real cost of ownership that you calculated, would that be any different from the perceived cost of ownership? Like when I'm actually making that decision, should I take that alternative or not? One, it is really contextual. So if I'm in San Francisco, and, so one is access to alternatives as we discussed, but two is how do I perceive it? So maybe I'm a millennial, I'm not, like maybe I'm a student, I'm gonna get a job soon, so I'll have the money to buy a car. At that point of time, what is the alternative costing me? And maybe I'm someone who's already owned a car for 3 years or 5 years. The way I perceive that cost is different, right? Based on age and context. So do you think how you could approach that kind of a question, and is there merit in approaching the perceived cost, and would that change any of the analysis on how we look at this cost?
So the answer is we didn't do that, but it probably would. Like I think people don't have a really clear idea of the total cost of vehicle ownership, and whatever their idea might be different depending on their current auto ownership status, right? Like if you're a millennial and you don't have a car yet, you're thinking about, you know, taking a different job, and you're thinking about, well, do I need a car if I want to take this job and all that? I mean, that's a very different kind of, and probably more careful calculation of how much that car really costs you than if you're someone that has had a car for 3 years and it's sort of like the default is just to keep it, even if it might make more sense financially to get rid of it and do these other things. And I think it is, I think those two, I think the decision to hold on to a car is really different from the decision to acquire a car, and we're acting like it's the same. That's a really good point.
Yeah. So in the focus group that we did in Sacramento, we figured out that most people, as Austin was saying, it would be out of pocket expenses. They would be just comparing the cost of alternatives, anything that we threw at them. It was like, yeah, it just doesn't make sense. I'm still paying so much for my gas and only so much for finance. So, you know, it just doesn't make sense. Still, it wouldn't make sense, even though it was like the first 5 years of the ownership and they were spending a significant amount out of their pocket every month. But still, a lot of alternatives, as you said, they just didn't make sense. But maybe going forward, that could change. But then, substantially, at least for the first 5 years of ownership, and I'm owning a new car, that amount is still going to be significant. And for me to take any alternative, first they are not like public transit, and others are not really reliable at most of the times. So really sharing a car becomes like a challenging thing.
Yeah, I mean, so there's the different way of thinking about how many cars I own, and then there's the different way of thinking about what mode I take for a particular trip, right? So if given my car ownership status, and those costs, like you're saying, are, yeah, they're really different. So that's where, let's see. So yeah, I mean, it's not here, but that the owned car cost per mile is about 17 cents versus the median. I mean, in this, I didn't do the median for this one, but it would be a lot higher. This is the only in high density. So you think it's, let's see, where is it? It's here, like 80 cents something. So that's, and I bet the variable cost probably doesn't change a whole lot. So this is adding parking. Doesn't change. So those are really different numbers. Yeah.
One or two more. Oh, well.
Yeah.
Will like interest rate change any of the scenarios that you're talking about? Like, you know, if you have a low interest rate, people will like buy more cars. That's the first question. The other question is like, you showed in one of the slides that like the cost of having a bigger SUV or a bigger truck costs more, but the utility that we get from bigger trucks is more also, I think. Like, because I live in an island where, like, you know, going to the beach, putting like buying a big truck, putting a soft board and barbecue, you think that like even like smaller cars.
Yeah, no, I mean, for sure. I mean, and there are certain kinds of trips that are really hard to make without a car and maybe without a pickup truck, right? Yeah, and then the question about interest rates, yeah, that would move the whole curve a little bit. I mean, well, depending on how much interest rate, it could move the whole curve.
I think all these things aren't changing your conclusion.
Right.
They may even be strengthening it, all the points people bring up. So we have like 2 more here. Let's do that.
Okay.
Not you.
I need to say something.
Thank you for your presentation. And so, yeah, according to the plot, so given that the average price of alternative is $1 per mile, from 10 to 40% of people will convert to alternative. But this is if we assume that all the people are informed of their financial status, of how much they are spending to their vehicle per year. So how do they know how much they are spending?
Oh,
the cost?
they don't necessarily. I mean, I think that's the same question Ali was asking, which is this? I mean, you're assuming that perceived costs are the same as your estimated actual cost, which is probably not true. And yeah, you're right.
Yeah, but
probably not true.
I was wondering something about low probability events such as crashes or tickets for policies in the fee or any part of the cost.
They're not part of the cost. That's an interesting question, especially the crashes piece, right? Like you could argue that, well,
It's part of insurance cost.
Yeah.
it's part of the insurance cost, but I mean,
They could raise the cost of bike.
yeah. Yeah, it pays the cost of walking and biking, and shared bike, and yeah. So
Medical.
yeah, right. So I don't, but and perhaps lower the cost of transit. Because transit is relatively safer. Yeah.
All right, Gil, you want the final word?
Yeah, because
Okay.
I have to say, Deborah, that I disagree with your conclusion.
What do you think I should say?
I think that what I see here, that even if we will double the cost of cars, it's going to be hard to do any change. If we will triple the cost of cars, it will be hard to do any change. And I would have said we need to double the cost or triple or quadruple the cost of driving where we have alternatives, and stop trying to shape cars, because we are trying for 40 years and failing, and let's actually show why we are failing, and start trying to shape more than driving. People will still have the car, can take it with the barbecue on the weekend, and we don't need to try to create an alternative that will take them with some other mode to barbecue on the weekend, but we'll just shade miles and put all of our efforts on shading miles when we can, when we have the alternatives. So taking one step forward.
And
that's kind of my conclusions from
I
your
will-
data.
I will further build on that. Another way to look at it is also that certainly this is very useful as a background thing to see what is the potential, but also a lot of these options by themselves will never be competitive with owning a car. We don't expect all trips to be replaced by taking Uber all the time.
Right, I mean,
But
that's
a
why you have to think
combination-
about a combination. So that's
Like
what this cost idea
Exactly.
is. That's what you're
So-
comparing it to.
Exactly. So what I'm really interested with, we're certainly really to look at things in terms of a mobility as a service point of view. If you see what are the monthly costs that people have, how you can have a combination of a flat fee for public transportation and unlimited access to bike sharing, and maybe a certain number of hours of car sharing, and how many users could be better off with some plans like that versus owning a car. Then of course the question is how many people will actually do it. Well, that depends on a lot of other things.
Yeah. Yeah.
We'll let Junia have the final.
So you're talking about VAT tax.
VMT tax is a good example, but again, VMT tax will not always give us the substitute. So we need to be, I think, more localized about where we are doing it, and this one blanket cost of miles, VMT, maybe not.
Well, that's for parking prices.
Parking price is a great one, yeah, all
Yeah.
of those, yeah.
All right, Deborah, final word. Thank you.
Thank you.